Welcome to the semi-regular WebGL San Francisco meetup. Welcome to the out-of-towners who are here, who don't usually come to these. That's one of the great things about doing this during a GDC. I'm Tony Parisi, co-chair of the meetup group. My co-chair Damon was here, and he'll probably be back in a while, Damon Hernandez, so find him. So in San Francisco, about once a month, sometimes every couple of months, we're trying to get these to be more regular. We have a meetup in the city, and the agendas tend to be pretty open, but we usually have one featured speaker. And we've seen some great stuff in the last 9 months since we've been doing these meetups. We've seen in-browser robot modeling, where you can model and print your robot and get it in the mail in a week from My Robot Nation. We've seen incredible shader type stuff from Google and stuff coming out of the lab, like HTML pages on surfaces. We've seen financial data visualization. We've seen Autodesk showing off DXF viewing right in a web browser for an enterprise portal. It's fantastic stuff, and WebGL is really on the move. Today our agenda is really open. We're going to just have a few updates from the core Khronos and WebGL group folks, and then after that, any of you folks who want to show off what you're doing, if you have a WebGL project, want to show a demo, we'll do a bunch of demo stuff, and then after that we can go into sort of birds of a feather mode and just have open discussions. And of course, even during the demos, feel free to do that and bust in at any time, and during the formal presentations as well. It's real free form, it's casual. This is great to have a suite like this where we can do it. So, just feel free to participate in any way, introduce yourself, talk about what you're doing, even if you don't have a demo to show. Okay, and with that, I want to introduce our first speaker, Neal Trevett, president of the Khronos Group, vice president at Nvidia. General all-around great guy. He's going to give us an update on Khronos and an overview of Khronos.
Yes, thank you everyone. It's good to see some new faces here. So I've got a few slides. It won't take more than about 10 minutes. But hopefully, for the new people here, we'll give you an introduction to Khronos, and we'll give you an update on WebGL, what's going on, some of the related APIs around WebGL. Hopefully, it'll be interesting to you. So we're at GDC, and so I just came from a MWC where we were talking about mobile gaming, and it's interesting to look at WebGL in the larger context of what's going on in mobile gaming. It's a very active area. A lot of the APIs that Khronos is developing are aimed at the gaming market, and of course the classic API that we all know and love, hopefully, is OpenGL ES, and we have a number of mobile devices around here from various vendors, and if you get a chance to see some of the demos on the mobile devices, you'll see that it's getting pretty hard to differentiate current generation consoles from mobile devices, even plugging them into 1080p HDMI-driven HD TVs. Actually, in many cases, the mobile devices are now looking better than the current generation of consoles. And of course, that creates a great foundation for WebGL. But looking a little bit further ahead, it's interesting. I think one of the next big waves in terms of mobile applications is going to be vision, using the camera as a sensor. The poster boy application is augmented reality, and no one really quite knows what that means, but all the cool technology we need to bring in cameras, to do vision processing, to do feature tracking, is going to be used in awesome applications. We just don't know quite what shape those applications are going to be. But it's kind of interesting to figure out how we can bring that into the web in the future. Another key input related to vision as a sensor is the rest of the sensors on the mobile device. The inertial sensors, the positional sensors, directional sensors. And we have the stream input working group that's working on defining APIs for that. And last but not least, of course, is WebGL and HTML5. So I was going to give like a little tour on a few of these APIs. Again, hopefully giving the bigger picture on where WebGL fits within the larger ecosystem of APIs that we're working on. And for those of you that are new to Khronos, what is a Khronos? Well, Khronos is an open standards group. We're open in two ways. We are open to any company to join, and in many cases we have individual members that are joining and participating in creating the standards. And the standards that we create are royalty-free and openly available to the community. we like to say Khronos is very driven by the membership. It's by the members for the members. It's the place where the industry can come and safely cooperate to create the open standards that pushes the industry forward. We have about 115 members, so ranging from the largest, we have Google and Intel, all the way down through all the silicon vendors, down to much smaller companies doing software, applications, tools, middleware. So we have a good representation from the industry. We try to be inclusive. We really welcome people to join and get involved. So starting with HTML5, many people here, I'm sure, are more familiar with this than I am, but we have applications that need to be ported onto an increasing diversity of devices. It's not just mobile phones and tablets anymore. It's your TV, and it's your set-top box, it's your car, it's going to be your refrigerator any moment now. But if HTML5 is going to be a real application development platform, it needs to be more than just more HTML. We need all the cool stuff that the native folks that are used to now on platforms like iOS and Android and BlackBerry are used to using multi-core CPUs, GPU compute, multiple cameras as sensors, image and vision processing. We need HTML5 over the next few years to have, I think, a vision on how we're going to enable web developers to enable applications to get to all that cool hardware that's being built even into your mobile phone. And so WebGL is like the first proof point, possibly, of a larger trend in that we can not reinvent all that native API goodness from scratch, but we can take the APIs that we've invented at the native layer and put many hundreds of man years into, and then lift them up into JavaScript to enable access from the browser. WebGL, obviously, is a JavaScript binding into OpenGLES. We actually do have another working group called WebCL, which is a JavaScript binding into OpenCL. OpenCL for compute, OpenGL for graphics. And I have a short video that will show you some prototype WebCL. But just like compute and graphics go hand in hand in the native space, I think if we can make WebCL successful, we'll find the same thing in the web space, graphics and compute going well together. There are standards like Web Audio that are being worked on at Google, and it's going to be really important for the mobile space to make sure that we can provide good acceleration for things like audio APIs that are available to the web developer, because power as well as quality is the key for good mobile applications. And then these yellow boxes are just ideas and brainstorming. But there is an increasing dialogue between the W3C and Khronos about potentially making some APIs like this for advanced camera control. We can leverage perhaps OpenMax for vision processing accelerated on the GPU and other hardware in the browser. A WebGL that taps that into the new OpenGL, and stream input can be leveraged for sensor fusion. We'll see. If you think it's a good idea, contact your nearest W3C person. So now Ken's going to be talking more in detail, but this is kind of our status slide for WebGL. Again, I'm sure many of you are very familiar with it. This is actually the anniversary, right?
Yep.
Of WebGL 1.0. Little baby toddler, 1 year old.
No champagne?
Damn it. Beer.
Beer.
Good, right? And at 1 year old, OpenGLES was nowhere. Absolutely nowhere. It took probably OpenGLES 5 years before it got the level of adoption that WebGL is already enjoying. So I think it's really interesting to look at the trajectory of WebGL, even compared to OpenGL. This thing's taking off like a rocket ship. And Ken will give us more details probably. The typed array spec came out of Khronos. We're talking about taking that into W3C. Yeah, we're going to talk about that. Yeah. And this is my favorite website, Can I Use? So the desktop browsers, with the one notable exception, are now shipping WebGL. But I think this year, this is going to be the year when you see WebGL beginning to appear on mobile browsers. And I think we have a couple of demos. I think the BlackBerry folks, are you going to do a demo?
Sure.
Yep.
All right.
And I have the Opera mobile browser, so I can demo that too. But it's going to be coming from all directions on mobile. So this is the year of WebGL on mobile. WebCL. So OpenCL is this parallel computation framework. You have you can write C kernels, and you have APIs that let you interrogate your parallel resources and deploy the kernels across your parallel resources, be they CPUs, GPUs, get the result. It's a very low-level API, and WebCL is a pretty direct binding to it. And we had a lot of discussion around whether WebCL was too low-level for a web API. Should it be higher? But in the end, we got a lot of feedback, and I'm interested to see if people still agree, that a low-level API was useful because it allows a foundation on which you can build a bunch of middleware. And the middleware can be very flexible if you have that flexible foundation. And it's kind of similar to WebGL. WebGL is lower than most web APIs, but again, it forms a stable foundation for a lot of innovation on top. So a few people were nodding there, so phew, that's good. So WebCL, we're planning to actually have the spec out this year. I do have a quick video. Some of you might have seen this already. It's kind of interesting to see. So this is the Samsung prototype. They made this video a few months ago now. This is running on a Mac in Safari. And they start with a simple WebGL demo. So it's a virtual environment with a couple of spheres. So this is a straightforward WebGL application. But then they turn the spheres into jelly blobs, and they're doing dynamic deformation. And there's quite a lot of floating point in those deformations, and the frame rate drops right down because right now we're overloading the JavaScript engine with that amount of floating point. But if you offload the floating point calculations back onto the GPU using the WebCL prototype, then the frame rate goes back up to over 100 frames a second. So just like, again, on the native side, very often to drive great graphics you need great physics or computation, simulation. We're going to find that WebCL and WebGL have fit together really well. You can see WebGL games that want to accelerate their physics engine as well as their rendering using WebGL and WebCL together. But under construction, we do have participation from the browser vendors in the WebGL working group, but the browser vendors, I will say this, because I drive Ken crazy, the browser vendors have not committed to ship this yet, but hopefully if you create a good, useful API, we will stand a chance of seeing it out there in real browsers. Really quickly, some of the other things I mentioned. OpenVL is a new name, but it's the name that we're going to use for the Vision library. So if you're doing applications that use Vision and you're in native space right now, this is going to be a standard we're aiming to get out this year, if we can. It's an acceleration layer for libraries like OpenCV that do Vision type processing. The GPU and CPU vendors will be able to optimize a Vision library that gets used by higher level libraries or applications directly. We have stream input, which is a way to connect applications portably to sensors, be they cameras or touch screens or inertial sensors. In a portable way, the application just requests semantic information, and the stream input middleware figures out how to give you a high quality sensor fused stream of sensor data. And you can request semantic information such as, am I in an elevator? Give me a call back if I'm suddenly in an elevator or I'm being carried in a hip pocket. The sensor guys know how to figure that out, very high quality and low power. And stream input will be the API that enables them to innovate and provide the API to the app developers to tap into this multitude of sensors that we're finding on mobile devices. there's a lot of, sounds like a magic, but we have some really interesting people in that working group. PrimeSense is the company behind the Kinect. They're the guys that actually do the depth camera in the Kinect. Soft Kinetic is their arch enemy, so it's great. They're actually cooperating in the working group. A lot of the key inertial sensor guys are there too. So a lot of good industry expertise that hopefully will create a really useful standard. And we have all these things kind of beginning to connect together. And again, this is kind of at the native level, we're no longer creating individual APIs. We're creating a family of APIs that are being designed to interoperate together. And over time, as we do the same thing, building out the APIs in the browser, and I think we'll want to pay the same level of attention to making sure that all these APIs interoperate to enable advanced applications beyond which we can do today. And so we can use OpenCL to implement OpenVL, which can accelerate a high-level library, which can drive the tracking that you use in stream input. And you can interoperate with OpenMax for camera control, and you can interoperate vision with graphics and compute. So all these things kind of hang together.
Neal,
Yeah.
can I ask a question
Yes.
here? I mean, today if I'm doing image processing, I'm using OpenCL on the server side. I mean, do you envision that OpenVL would be, using OpenCL functionality to do?
It's one of the design requirements so that is possible, and that would be a good match. But like any Khronos standard, we don't mandate an implementation mechanism. So you'll be able to use other implementations. But yes, I think many people will implement their OpenVL over OpenCL.
So today we have OpenCV, which is an open source implementation. Is there envisioned an OpenVL reference implementation? I use reference loosely, not in your formal term, right? Sample implementation that's proposed?
Yeah, the OpenCV is actually that's actually where the conversation started.
Okay.
And OpenVL and OpenCV will be very complementary because OpenCV is very widely used and it has lots and lots of cool functionality, but it's very hard to accelerate because it is a collection of 1,000 or plus functions just in open source. So in almost all cases, it's not always true. I mean, Nvidia puts like 20 of the functions into CUDA and stuff like that.
Yeah.
But the norm is that they all end up running on the CPU because it's just C code. And you can say, okay, we'll implement 20 functions in hardware, but oh my god, now we have 980 still to go. It's kind of an impossible task. So OpenVL is going to be a implementable API that the silicon vendors can invest in. And then the next generation of OpenCV, and we have the OpenCV maintainers in the working group, the next generation of OpenCV will have the chance to increasingly use the OpenVL as an acceleration layer. And so OpenCV implementations will be able to tap directly into the hardware resources on the system. But it's much lower level than OpenCV. It's a hardware acceleration layer.
Okay.
But applications that are keen, applications can use it directly if they wish, of course. But we see the normal mode will be either OpenCV or other high-level libraries will tap into the acceleration through OpenVL. Okay, so we have then this ecosystem of standards. We have these native APIs, graphics, compute, imaging, and sensor processing. And you can see we're building out the web APIs slowly, and we have like an opportunity, I think, to figure out what to do, building out into these vision and sensor domains. So I want to finish up with a few liaisons that Khronos is doing, and some of you are working in some of these other organizations. An increasingly strong link to W3C, of course. That's where a lot of the web is being defined. WebGL, WebCL, sensors, video and camera. But also just look more and more connect points between GPU hardware and the web standards, CSS shaders, the composition in the stack, audio, SVG, Canvas accelerating on the GPU. I think a lot of the GPU vendors are getting increasingly involved, and we want to be there. The Web3D guys, they have X3D, which is son of Vermal, are now implementing what they're doing on top of WebGL, and I have a diagram about that. ISO, JTC1 SC4 is adopting Collada as a CAD standard. SC24 Working Group 9 is a new augmented reality working group. They've already decided to use the Khronos APIs as their reference platform. And OMA and Open Geospatial Consortium, they're doing a lot of augmented reality stuff too, and we're working closely with those guys. The declarative 3D is interesting. It's not exactly X3D, it's kind of a derivative of X3D. There's a W3C community group right now that's driving this, which means it's open to everybody. I think it's synergistic to WebGL. It's putting the 3D scene graph in the DOM itself, so it makes it accessible to a new strata of web developers. And whereas you have Canvas and SVG, an intermediate API and a scene graph API, you can draw the same kind of diagram where WebGL is an immediate node API and XVDOM is a scene graph API. Different strengths and weaknesses, and different types of developers will find different ones attractive.
How does one get involved in that, Neal?
Well, it's a W3C community group. So you go to W3C website, search for community groups, you get a list. There's a fairly new mechanism, so I think it's like 5 or 6 ongoing right now.
Just imagining Thermal getting reinvented, shuddering and sweat.
You shouldn't shudder. No, this is good. I think that the declarative 3D, because it's leveraging the DOM, leveraging WebGL, it's not reinventing any wheels, is adding value to a large swathe of web developers. I think it's a good thing. And then we've had lots of discussion on this earlier in the Collada, but I'm interested, perhaps after, when we're chatting, if people see this need for a 3D transmission standard, because there's this approaching chaos. Audio has MP3, video has H.264, images has JPEG. What does 3D have? We don't have anything, and we need to have a transmission standard, else we're going to end up in a worse mess than the video guys. And there's lots of things we can do, and there's work going on at Google, there's work going on at MPEG, but we need to, I think, as a community, take concerted action to actually do something before it's too late. So I'm really interested to see what people's views are on this, and whether we should do it. Is there a real need?
Is that related to the previous one?
No, it's completely separate.
Okay.
So, I mean, the MPEG guys
seem like they could be closely related. So, anyway.
Well, WebGL is going to really need this. WebGL is one of the primary drivers for this, right? Because else the browser guys, if there's 25 different proprietary formats to actually use to send 3D data across the net, either you're going to have to do with the decompression or decoding in JavaScript.
No. Oh, sorry, I thought you were going to say in the browser.
Right. But if there's 1 or 2 that are really good, then we have a chance of the browser vendors considering, like the video codecs. Yeah.
It's a possibility.
Possible. It's a matter of adding value, right? Eventually. Then finally, we just came off the Collada meetup earlier, and
Can I actually ask, can there follow up if I may?
Yeah.
So is it feasible to implement the donut without the hole? I mean, you allow a plugin to go into that stream?
Into the 3D data stream coming in. The thing is, look, this is all my opinion. I don't want to say this is the opinion of Google.
And we can take it offline, and I can give you more beer. Right now.
Take your shirt off if you're gonna.
Oh right.
It wasn't that kind of.
Yeah.
There's a problem though. All right, but basically, I'm a little dubious about how exactly you would wedge the 3D format into the browser itself, and how that would be exposed via JavaScript APIs efficiently and effectively. I mean, it would really boil down to defining a 3D streaming, I assume, file format where you can, efficiently extract, vertices, texture coordinates or multiple texture coordinates. Have really a lot of customization possible because everything is shader based and there is no fixed function pipeline that you can target like there was for VRML. So if, hypothetically speaking, such a format were introduced and support was embedded in the browser, then yeah, you probably have to figure out some processing pipeline. But I personally like the direction of figuring out how to let JavaScripts download stuff efficiently. And we can talk more about that.
Yes.
I don't need to.
No, no. It's all good. You need to solve the problem somehow.
We do have to solve the problem. Compression of this data is extremely...
Yes, yes. But from a hardware vendor's point of view, just to...
Sure.
I mean, if we can decide on an efficient format sooner rather than later, then the hardware guys can begin to build the hardware for it. Just like we build hardware for H.264.
It's true. I do wonder whether the decompression phase is, it's orders of magnitude faster than the actual downloading of the data phase of the network. So I think that coming up with really efficient compression schemes is
right. Yeah. But if you're processing gigabytes, and soon we'll be dealing with huge models.
That will be a great problem to have.
Yeah. We have to plan for it.
Sure.
Okay, and my final slide is Cloud WebGL. Sinji, we had a great Cloud meetup, and there's going to be lots of good Cloud news coming any moment now. So we're going to re-energize Cloud as a great authoring interchange format, and making sure that it works really well with the WebGL community is obviously one of the major use cases that we need to make sure are really well served. So making sure that we have great Cloud import into frameworks like 3.js, the transmission format stuff we were just discussing. If you're interested in Cloud and authoring, come and see me after. I'll give you a recap of what we just went through this afternoon.
Great. Thank you, Neal.